This is AP Calculus, lesson 8-2. We're talking about total change today. So first I want to talk about what happens when we have a graph of rate, or just in a situation where we're talking about rate and we integrate it. So this is the graph. I should call this, well, we're always talking about rate in this unit. So this is a graph of rate. So when I integrate that, remember integration means that we're taking an infinitely many number of these bars where they have the height that is dictated by the function, and then the width is infinitely small. So they're really, really skinny rectangles, and I have an infinite amount of them between a certain range, in this case between 0 and 30. So what happens when we find that area? What happens when we integrate the rate? What do we find? So I'm really analyzing this bar, and I should drag this off to the side to talk about him. So this is the same bar over here. What were our units for rate? What is the height here? What is this distance here? So yeah, it's per time or per, so I think it's something over time, right? So what should our time be? What was one of our last notes?
People per hour.
People per hour. So let's make this one per hour. And this is the number of people. Hold on. So we have to be careful here. Since this is a rate, the height right here, this says, like if I took this point right here, this would be people per hour at that point. So the y-axis here, the units are people per hour, because this is a rate graph. And then our axis down here is in terms of time. So when I analyze this bar here, I have an hour, I have people per hour, people per hour. So what happens when I multiply these two units together? What do I get?
You get people.
You get people, yeah, because the hours will cancel out. So the area here is people. And how does this relate to Unit 7? When we take the integral of, what do we have in Unit 7? Integral of velocity. Do you remember what that turned into?
Position.
Something about position. What specifically about position was it? It was the total,
Distance traveled.
careful, total distance traveled is the equation where you have,
Change in position.
it's the total change in position, exactly. Yeah, so total change in position, or the total change in people in this case. So when I'm talking about example 1, this is the same info as our notes from the other day, so that's talking about, that's example 2. That's talking about example 1, where we have a cylindrical can in Stormville. Oh, that is not the right program. Okay, so explain the correct, or the, with correct units, the meaning of this integral. So this was the rate of water collected. So how are we going to translate that? And we can start off our sentence. The integral between 0 and 30 of s prime of t means, or dt, means what? Instead of total change in displacement, this is going to be total
Change in people.
Careful.
Position.
Let's look at that example again. Total change in what was our height? ST is measured in milliliters.
Milliliters.
Yeah, so it's going to be the total change in milliliters. And what are milliliters? It's measuring what? What in this problem do we see?
Water.
Water?
Days.
What specifically about the water?
The height.
Yeah, there it is, the height of the water. So it's the total change in the height of the water.
Wait, we're not dealing with the people per hour anymore?
We will, that's example 2 though. And we will deal with that one. And then what were our units again? We had,
Milliliters per day.
careful now. So now that we're taking the integral, we got rid of our per time.
So just
Height.
So it's just the height, and what are our units for height? It's right here. It's
milliliters.
just milliliters, yeah.
Wait, didn't we already say it?
Oh, okay. If you did, I apologize. Wait, is it oh, I think there's an error over here.
No.
Sorry, there should have been millimeters. You can't measure height in milliliters. That's measuring volume. That makes more sense. You're measuring height.
Nice. I gotta fix that.
Okay, and then what does this 0 and 30 mean?
Day
From-
0 to day 30.
Yeah, exactly, in days. So 0 to 30 days. So this part A right here, can we make a note on the side? I'm going to do an AP with the circle, and that symbol means that is a very common AP question. They always love asking, explain the meaning of one of these things using correct units. Be ready to face those on the AP test. That is an AP certified question right there. All right, let's move on to part B from that same problem. So, part B. So, how many millimeters has the height of the water increased from time equals 0 to time equals 30? All right, so first of all, let's set up an integral because we know that's going to be going backwards. We're talking about height displacement, the total change in water height. So it's going to be the integral from what to what?
0 to
30 of, what goes in here? What are we talking about? What function?
S prime.
The s prime, yeah. S prime of t, again, was the rate. S prime of t dt, very good. Okay, now we need our calculators. All right, so we have our function here, so that should still be entered from yesterday, or maybe not if you were working on the homework. So we need to plug in
I hope I was working on the
Me
whole
too.
2 sine of 0.03 variable. All right. And our window now, well, actually we don't really need our window because we can do it the quicker way. So let me go back to this other one. So we have our function. We need to take the integral of that function between 0 and 30. Review how to do that, ladies.
Math.
Math?
9.
9.
And do vars,
Vars.
right?
Right.
Enter, enter.
Comma.
Comma.
X.
X. Why do we do an X there?
Respect to X.
Yeah, with respect to X, that's the variable we're integrating with.
0,
30, perfect. And then the bounds. All right.
25.226.
There it is, yeah. So that's going to be 25 point, and we always go to 3 decimal places. 226. What are our units here?
Millimeters
Millimeters or millimeters per
Per
day.
day?
But isn't it the integral?
Isn't it what?
Isn't it the integral of it? So then it would just be height.
It would just be height, yeah. So it's just millimeters.
This means
Yeah. So whenever you have the integral of rate, you only have that first unit, no per time. Perfect.
Mr. Sandel,
Yes.
how do we know, like, just to do, like, when to do just 25 or do 25.226? Like,
So if you're
just-
talking about people, you can't have 0.226 of a person. But if I'm talking about height or time or money, it depends on the currency for the money. But usually any other unit aside from humans or counting solid objects, you'll be able to do decimals.
Okay.
If you're counting number of blocks, you probably can't do half of a block unless you have a saw or something. All right, so let's talk about our second example. So example 2. right, so this is going to be same info. Come on now, type. Same info as our notes from as notes 8-1, and now we're on number 2. Could put parentheses around there. All right, so now we're going on to part A for this question, and that is how many people entered the park during the first 4 hours? I guess that should be a question mark, shouldn't it? And if you want to set up the next question, how many people leave the park during the first 4 hours? And the last question, it's part C.
You cheater.
Copy and paste. No, is
Is this the last part of our notes?
yes. This is going to be the very end. That's the last question for part C. What is the total change in the number of people during the first 4 hours? And please don't actually write out all these words. You can do, for part C, this is kind of what you do in your notes. You'd say, for part C, total change, people, or in number of people, first 4 hours. That's how I'd write it in my notes. I wouldn't actually write all of this stuff out unless...
Thanks for telling me. I wouldn't get that though.
Okay, well, you can abbreviate however you'd like. But notes are supposed to be not writing verbatim what the teacher writes. Hopefully you change it a little bit to suit your needs. All right, we have it written down?
Yeah.
Okay, so what is part A asking for? How many people? How can we relate that to the title of the notes?
Total change.
Yeah, so how many people entered the park? That's really asking for this word right here. How many people? That's really asking for total change. All right, so how do we, we can obviously punch it in our calculator, but what do we write out for the AP graders so they know what we're talking about? What are we doing on our calculator? We're taking, integral between 0 and, careful, not 30.
60?
So it's in the question for A.
4?
4, yeah. And then we don't want to write out our whole function, so we're going to be lazy and we'll say we're using the e function, e of t, dt. And if you need to make a note from the last notes, this is a rate. E of t is a rate. Because it's clear in our first part B that this was a rate because it was s prime of t, but now it's not quite clear, so that's why I'm making this note.
Okay.
And what type of rate? Is it a increasing or decreasing rate for E? Like, is it entering or leaving, essentially? So it's going to be increasing. So you can do it's the increasing rate, the plus rate, the positive rate. All right, calculators, what are we going to do? Sorry, I heard 2 people. I think first, we do need to enter the function, and then we need to do basically the same thing. So our function was, for example, 2. And we need to enter both of these because I did see a question about leaving, so let's go ahead and get those out of the way. So 8, 6, 0, 0, divided by, keep your parentheses here for order of operations, all this stuff. All right. Have those equations, double checking. They look good. All right.
Wait. Okay, never mind. Okay.
All right. So, tell me what to do now.
Second quiz.
Second quick.
Perfect.
Math.
Math.
9.
9.
We're gonna do bars over into.
Okay.
Comma. X. Comma. 0. Comma. 4. Close parentheses.
Yeah. Do you need to close parentheses?
No.
Nope. Yeah. You can save time.
You should.
You should. Notice I haven't made this point, and I should have made it yesterday, that when I'm writing out my answer, I don't write equals because it's not strictly equal to 25.226. There are numbers that come after this. So I say it's approximately equal to, and then this number, 91.424.
Will we get marked down if we do equals?
Nope. But you should get into this habit because it's more formal, especially when you go to college. It's these little things that impress your professor. They know that they're really approximating because it's not exactly 91.424.
Okay.
And it impresses me too because it lets me know that you know what you're doing. Yeah, perfect. So that was part A. What do we do for part B? It's very similar.
So now we do the same thing but with.
Yeah, same thing with LT, as Joe said. So DT. All right, Joy, tell me what to do on the calculator.
Okay. Go math. 9.
9.
And then no bars. That other,
Go right.
that way. Yeah. And then balance. No, the second one.
Oh, it's the second one. Okay, bars, right. Enter the second one.
And then X and then 4.
0 to 4.
Yeah.
All right, perfect. All right. So we have 134.483. Oh, what are we doing wrong?
We forgot our unit.
No. What are our? Oh, yeah. Okay. So that's a great way to segue. Yes, we are forgetting our units, and because of our units, these numbers are going to be wrong.
Incorrect.
Yes.
Dang it. So do I get a point because I know?
Sure. I'll give you a point. Cool. So what should our units be for the first one? Shout it out.
Hours.
Here, I'll go back to the problem so we can analyze it.
Oh.
People entering per hour.
People per hour.
So yeah. So E of T measured people per hour. This one was people per hour. So when we come back here and we take the integral, what are our units now?
So now it'd be
Just hour.
91 people.
People. And Carly had the correct answer there. We're measuring people, so
91.4 people.
it's easier to just grab everything and delete it. Come on now. Drag. And same thing for part B. We're talking about people here.
134 people.
And we still have our approximately because we don't know if they were meant to round up or down. So I'm still going to make it approximately. Perfect. And part C, our last part before we're done with our notes. What do you think we're going to do here? It's very similar to our notes from 8-1.
Don't you subtract them?
You do, yep. So this is the integral between 0 and 4. Should I have two integrals or should I have L of t minus E of t inside the integral?
Inside.
Inside or outside? What do you guys think?
Both.
Both. And we can compare them and see if they're the same, right?
No.
We could do both. I'll tell you this, they'll be the same if you did them individually. So I'm going to write it all out formally. ET minus LT. I want to put them inside the same integral because it's faster for me to write. That's the main reason. And this is going to be dt. I guess we forgot to make our note here that this one was a negative rate. So now this thing is going to be what type of rate? I mean, it will be a negative number, but this is the total rate. Total rate. And again, it's going to be an approximation because it won't come out exactly. And we could go on our calculator. I think we should go on our calculator to make sure that we have these numbers rounded correctly. So to do that, we can do second enter, do that, minus, and then we can't hit second enter again, but we can enter it all again. Math 9, and do all this stuff.
Oh, that's a pain.
Y2, comma x, comma 0, comma 4. So I'm basically saying do the integral for y1, subtract integral for y2, and find what that's equal to. And it should be negative 43. And we could have just done this straight away, and it would have given us the right answer.
That's what I did.
That's a pain.
I just did this to be sure. Cool, that's all we have for the notes. Yeah, so write our summaries, that's the end of the video.